Hello, I'm going to be talking about the poster I'm presenting called A Reprocessing of 1 kilometre Level 1 Data from AVHRR HRPT Archives and of the ATSR series. This is basically a poster that's describing two current projects which have started this year, which are looking at a reprocessing of both the AVHRR HRPT data held at ESA and associated archives, and also about the fifth reprocessing of the ATSR series. So in terms of the AVHRR project, this is led by the University of Bern along with the University of Reading and MPL and SMHI, and it aims to reprocess the current HRPT archives held in Europe by ESA, but also will include HRPT archives from South Africa, Kenya and Argentina. And the processing will also include the current holdings of the AVHRR LAC data held at ESA. So a reasonably comprehensive set of 1 kilometre HRPT data going back to the early 1980s or late 1970s. The idea is to reprocess all of the data into a unified format, which will be the ESA SIP data. And as part of that, it will be processed through a software package called pyGAC, which, if you don't know, is a Python package to read AVHRR data. And all of the developments that will be included will be embedded into pyGAC, which means if you have your own HRPT data of the right format, you can basically generate your own data as well. The developments will consist of improvements to the calibration. We are looking at, and we'll be shortly deciding as to what we consider to be the best visible channel calibration that can be used. As many people will know, there are many different calibrations that are available, and we will select the one that we think is giving you the best visible channel calibration. It's likely to be between Patmos X and Mitram, and the figure here shows the difference between different visible channel calibrations in terms of the gain, and you can see there's actually quite a lot of variation between different calibrations. Of course, we'll also be looking at the infrared channels. We will be probably sticking with the operational infrared calibration from Walton et al. 1998. This is because within this project there is no time or effort available to completely set up and derive a new calibration. But on top of the Walton calibration, we will of course be looking into some corrections that potentially can be added to it. For example, it's been known for a very long time that the calibration system itself can be contaminated by solar radiation, and we are developing an algorithm within pyGAC to remove this solar contamination in the 3.7 micron channel. In the calibration system, we will also provide a flag to tell you when there is likely to be solar contamination in the 3.7 micron channel field of view. There will be an option to generate an updated calibration target temperature. This is because it is clear that there is an associated calibration error with calibration target temperature, which is likely to be at least in part related to thermal gradients across the calibration target. The algorithm itself is not been finalized, it's not fully developed. It seems to have promise, but an awful lot of testing needs to be done to make sure that issues such as orbit drift and differences between different AVHRR designs is properly taken into account, and that work hasn't been done and won't be done under this project. But we will provide a potential update to the temperature, in part just so that you may understand where you're likely to get more error and the sort of scale of target temperature error you might get. And of course, we will be providing an associated uncertainty with the calibration target temperature, which will propagate through into the uncertainties that will be provided. And we will be providing uncertainties for both the visible and the infrared, based on the Fiducio methodology, essentially. And then also we will be updating the geolocation of the of the HRPT data provided using ground control points, which in general will give you should give you a geolocation better to approximately a third of a pixel. We're still working out what we need to do about times when it doesn't work, but for many cases you'll get that kind of geolocation accuracy. Then there's the ATSR reprocessing, the fifth reprocessing. Of course, there's a number of things that will be undertaken as part of that. There will be any problems that arose due to the fourth reprocessing will of course be fixed. There will also be some updates to some of the algorithms that were part of the reprocessing, such as improvements to the ATSR cloud mask, because there was a bug in the fourth reprocessing. And there are other algorithm updates as well, which are listed here. There will be an update, of course, to the geolocation, which is being worked on at the moment. And we will be looking at the calibration, both visible and infrared. In the visible, the updates will include relooking at PIC sites, such as desert sites, to understand problems with the visible calibration. And in the infrared, we're going back to the original pre-launch data. So we will have uncertainties based on the pre-launch data, both random and systematic components propagated through to the final radiances, plus other components that we deem necessary. And we also will be at least having a reference against a different calibration equation, basically so we can begin to understand if we're potentially missing components of uncertainty, the sort of scale they are. We're not intending to completely rewrite the operational calibration, although the updated calibration, which has been quickly run through the pre-launch, does appear to be somewhat better than the operational calibration, but that's only a single use case. And again, within this project, we don't really have the time to do the full analysis that will be required. But with the current calibration, you will get pixel level uncertainties as part of the reprocessing. So both of these projects are running now. They both started this year. The AVHRR project is due to end near the end of 2025 in November, and the ATSR project reprocessing is due to end in February of next year. So in 2025, you should be able to access high quality reprocessed AVHRR HRPT data for certain domains within the world, primarily Europe, Africa and South America, and you will get a full reprocessed ATSR, ATSR1, ATSR2 and double ATSR data record, again including uncertainties. Thank you.